From last week. Shh. What is the first step to any factoring problem?
What number goes in all?
Yes. What is something that's common for every problem? Sometimes it's a number, sometimes it's a variable, sometimes it's both. What was common in this problem? Very good. The 3. So we factored out a 3. And Caitlin, what did you get after you did that?
N2 plus 7n minus 8.
Very good. N squared plus 7n minus 8. After you've done that, now what can I do? What's step 2? No, that's not it.
The n plus and the n minus?
That's right. Step 2. Do I have a quadratic? A quadratic is anything that starts with an n squared and has 3 terms. Do I have a quadratic? Yes, n squared, 3 terms. So now, I need to try to find 2 numbers that multiply to get this number and add to get this number. Now remember the keys from last week. The negative. What does that tell us? Anybody remember?
There's a plus number.
That's right. That's exactly right. If this is negative, the second sign, that means you're going to have 1 plus and 1 minus. And if they're different, what does the first sign tell you?
That the bigger number is positive.
Exactly, that the bigger number is that sign, so the bigger number is positive. What are all the factors of 8?
1,
1 and 8 and 2 and 4. Now we know the bigger one has to be positive and the smaller one has to be negative, so plus, plus, minus, minus. Which of those pairs add up to be positive 7?
8.
Negative 8, positive 1, so positive 8, negative 1. There you go. Now, factoring. Here's the thing. We mean positive 8, negative 1? Did I say it backwards?
It has to be 2 numbers that add to get.
Yeah. 2 numbers that multiply to get 8, so we write down all the factors of 8. 1, 8, 2, 4. Those are the only combinations. Then you have to know that the first one's going to, or the bigger number is going to be positive, so I knew to make these 2 positive and these 2 negative, and I knew they were different because that's a minus sign. And then you just look for the 2 that add up to get them second term, positive 7, and it was the top ones. Now, you're going to have a quiz Friday and a unit test next Friday, right before fall break, so you don't have to remember anything over the break. Now, come time for that quiz and test, your directions are not going to say factor this specifically like quadratic. You're just going to have a huge section of problems that are going to say factor. And between now and the end of this week, we're going to go over so many different ways to factor. So that's why I'm giving you this step 1, step 2, step 3. Because starting today, I'm going to start having problems in there like, even though we're learning something new today, there's going to be a problem almost exactly like this one in your assignment. To make you remember, oh, when I'm factoring, I have to remember all the different techniques. So there's going to be a problem like this, as well as what we're learning today. So it's important that you keep up with these notes. So, questions on the DOM? No? Okay, good. Well, if there's no questions, you can put that DOM away. And I am going to go to the next slide.
Are we still doing the factoring?
Yes, we're still factoring. Still factoring. All right, so to go to the next slide, I have to fast forward my video. Oh, come on, fast forward. Blah, 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 blah. Come on. Okay, pause. Okay. All right. Now, time for you to add step 3. Step 3 to your factoring stuff. Step 1, is there anything in common? Step 2, do we have a quadratic? Step 3. Now, step 3 will come into play if you do not have a quadratic. You're going to kind of make your way down the list. What? Yes, we did. That's what we just did in the DOM. That was a quadratic. There's a video online. Okay, now, step 3. If it is not a quadratic, is it... Now, this is going to make more sense after we talk about it, but go ahead and write down the third step if you're keeping up with these.
Is
And
it
hope.
prime?
No, that's actually, well, technically, after all the steps, if none of them work out, then it'll be prime.
Oh.
Okay, step 3. Is it a perfect square It's really hard to write on here, so I apologize for the Corey-like handwriting. I mean that as a compliment. Is it a perfect square or cube? Is it a perfect square or cube? And I'm going to show you how to notice those two things in a second, but step 3 is you need to be able to discern, is it a perfect square or cube? So step 1, anything in common? Step 2, quadratic. Step 3, squares or cubes. All right, now if it is a square or cube, then you are going to need to reference the following page of notes. The following page of notes. Okay, boom. Write those down. Those are the 3 formulas you're going to need today, and we're going to talk about them after you have a chance to write them.
Wait, which one do we write?
When you do these, here's an example of one. Let's say we had 4x to the 4th plus 108. Plus 108x. Step 1. Is there anything in common we can take out of that? X, and what else?
2.
You could take out a 2. In fact, you could take out 2 2's. Yeah. And when you factored out that 4x, you would get x cubed plus 27. Now, here's a huge bloody hint. This is where you'd work your way down. Is this a quadratic? No. Is it a square or a cube? There's normally going to be a variable in it. That variable is going to have a big honking exponent, in which case you can tell, is that a square or a cube? What is this one?
Cube.
It's a cube. So you'd be like, I think I'm looking at a potential cube problem. All you have to figure out now is this a cube? Is the number a perfect cube? And that's what I'm going to show you how to do. To find out if the number is a perfect cube, this is all you have to do. Now I have to take this off the board in order to show you. But before I show you, again, let me reiterate. You'll be staring at a problem with a variable that's going to have a 2 or a 3 in the exponent, which will be a glaring hint. And every single problem today, and every one I'm going to put on your quiz, and every one you're going to see in your unit test, I'm not going to throw you any curveballs. If there's a cube there, or even a square there, and there's only 2 terms, it's going to be a perfect cube or square. You just have to find out what the perfect cube of that would be. Excuse me, cube root.
So second is usually perfect.
Yes, exactly.
It's more or less a simple thing.
I'm not going to give you curveballs. Now, here's how you're going to find that out. All right, exit out of this. Discard, exit the video. You're going to need to have out a calculator today. You're going to need these for like every problem. What was the one we were just doing? Was it 27? X cubed minus 27?
Doesn't matter what kind you've got to roll.
Now, there is a cube root button. Shh. But like I told you guys about a week ago when we were doing radical problems, any radical can be done with an exponent. So, you're sitting there looking at x cubed minus 27, and you're wondering, is 27 a perfect cube? So you just need to tell the calculator to take the cube root of that number. By raising it to the 1/3 power, please notice that 1/3 is in parentheses, you're telling your calculator, what is the cube root of 27? Hit enter. And like I said, they'll all work out for you. They all will. This 27 is the same thing as 3 cubed. 3 cubed. So you could go back to your problem, which I'm going to have to reboot up as a video. You could go back to your problem. Oh, it's a playing video. Stop playing. Grapples. We'll just do it on this page. So you'll go back to your problem, which ours was x cubed minus 27 after we factored out those other 2 pieces. And you could say, okay, the cube root of 27 is x cubed minus 3 cubed. That was the whole point of finding the cube root of this. We want ours to be 2 cubes right next to each other. Corey, you getting this?
Yes, sir.
2 cubes right next to each other, which it now is. We have x cubed, and I broke this down into 3 cubed. Now, before I go any further, are there any questions about how I got from here to here? Your calculator. Take the cube root of that number by raising it to the 1/3. Boom. It'll tell you what the cube root is. So you're right, it's the last one. At this point, you have to say, okay, I'm looking at the difference, subtraction, of two cubes. That's this one. And all you have to do is rewrite this into this. This is the factored form. So, here we go. My A, X is going to be my A, 3 is going to be my B. And I'm going to rewrite this exact line, filling in those for my my A's and B's. So it's going to be X minus 3 times X squared plus A times B, so that's 3 times X, plus B squared. What's 3 squared? I think it's 9. Boom, there you go. That's a 3, by the way. It just didn't come out very squiggly. And there you go. That's it, fully factored. X minus 3 times, of course you would have the part we took out, but I forgot what that was, so I left it off. X squared plus 3x plus 9. You just punch them straight into the formula. Today you don't have to go looking for factors of numbers and two numbers that multiply this and add to get this. These are easier because they're just a formula. All you've got to do is plug them in. That's all you've got to do. Now technically, you're down to a quadratic here. And technically, you should be trying to say, hey, that's a quadratic. Could I do that? But I'm going to tell you right now, when you factor it like this, these will always be prime. There's nothing you can really do with the rest of those. So you don't have to factor that quadratic. That's going to be your process all day. Is it a square or cube? Which one is it? Write it as two cubes. Identify what your two cubed pieces are, x and 3, and then fill out your formula. And that's it. That is it, fully factored. Questions on that one? All right. Then let's look at a live example. Discard. Let's see. Oh, here's one. Oh, back up before I start working. Pause. Okay. Step 1 is what?
Anything in common.
Anything in common. What is in common? X and what? 3. Very good. X and 3. If I divide 3 and x by both pieces, what do I have left?
Y2.
Y squared. If I divide the second one by 3x, x's cancel. What's 48 divided by 3? 16. Very good. 16. So, step 1, done. Step 2, is this a quadratic?
No.
No, there's not 3 terms. Step 3, is it perfect square or cubes?
Square.
Perfect square. Made blatantly obvious by that. What's the square root of 16? 4. So I can rewrite this as 3x times y squared minus 4 squared, which is what you want to do. You want to write it as 2 squares. Then you say, oh, sweet, 2 squares. I'm just going to go back and look at my formula. So y is our a, 4 is our b. What was the formula? Who has that?
It's the difference of 2 squares.
A plus b, so y plus 4, and a minus b, right? And a minus b, which would be y.
What? What? What's at the bottom?
That's the final answer.
I don't understand.
It's all right. We'll go back. Do you get how we got this step?
Yeah.
Okay.
If A was, I thought Y was A.
It is.
Then why is there a 3A?
Because that's what we took out in the very beginning. That doesn't go away. That just hangs around.
I don't see how you know which one is which.
Good question.
Does that make sense?
Yes.
Whatever comes
Whichever one is first is A. Whichever one is second is B.
Which what?
Y or 4. Y or 4. Bless you. In your formula, I know you're just coughing, but I'm a blesser. In the formula, it was a squared minus b squared, right? A squared minus b squared. So y has to be your a, and 4 has to be your
If
b.
you look at the
Oh,
formula.
so you keep the 3x.
Yeah, that just comes right down. It should have done it on the last example, but because I had to take it off the board, I forgot what it was. I'm sorry. I know. Sorry. 58.
Is that y plus 4 and y minus 4?
Yes, ma'am. Which is what the formula said. Didn't the formula say A plus B and A minus B?
But what I don't understand is it says the first of it. It says a squared plus b squared.
No, it's A squared minus B squared. That's showing you what you're going to be looking at before you factor it, which is what we had. We had two perfect squares being subtracted. And that's what it's saying. It's saying when you're looking at some A squared minus B squared, which is what we had, then you can factor that into A plus B, A minus B. That's what it was saying. Does that answer your question? Okay. Other questions? Yeah, the first part on the left side of that equal sign, that's not what you have to do. That's what you're going to be looking at. All right. Questions? Whatever you factor out in the beginning is just going to come straight down. You have to hold on to it. It doesn't just vanish. We're going to be graphing here pretty soon, in about a week or so. And you're going to be able to look at this and be like, okay, I know this crosses the x-axis at 0, -4, and +4. That's where all this is going. It's going to really help you graph. One more. One more example. Really hope I get this software stuff figured out. We already did that. Already did that. Already did that. Oh, here we are. Oh, that calculator's going to be in our way. Oh, well. Okay. Oh, you can see me start raising 8,000 to the 1/3 power. Step 1. Is there anything in common that can come out? No. Step 2. Do we possibly have squares or cubes? Cube. Very good. Because h is cubed. Well, what you need to do now, find the cube root of 8,000. 20. Very good. You took 8,000 to the 1/3 power. So you now have 8,000 up arrow. Yeah. And then parentheses 1 divided by 3.
My calculator did that.
I don't know, but you're welcome to use one of mine.
Well, I want to see if mine does. Probably not.
I bet it does. Yeah, it does.
Where?
I'm looking. Well, you've actually got a complex root button.
Thought you were in heaven. What time we go to lunch, Crawford?
58.
58.
58. Of course, you have a cube root button right there. It's right above your 0. So type in 8,000 and then hit second 0 and it'll tell you. All right. So cube root of 8,000 is 20. So we can rewrite this as h cubed plus 20 cubed. Now, do I have the sum or difference of two cubes? The sum. And that says, if you have the sum of two cubes, let's declare our variables. A is h, b is 20. If we have a sum of two cubes, what does the formula say it's going to be? Oh, okay. A plus b, go on.
A squared.
Pick all this stuff up. Whoever's throwing it, I don't care who it was. A squared
Minus AB.
minus AB. So minus A times B, which is just 20 times H. Then what?
Plus B.
Plus B squared. So 20 squared would be 400.
We have to write 400 or?
You can write 20 squared. That's fine. You should know on your test, they're going to go ahead and square it. It'll be 400 on your test. But that's fine. I don't really care how you write it today. That's fine. 20 squared. So, there you go. It is factored. Questions? Again, technically, you should be looking at this and being like, ooh, quadratic. Can I factor that? But no, it won't factor it. Fine. So there you go. You have factored this into this. If you've got your formulas and you've figured out how to take the cube root of a number, today is actually pretty much straightforward. There's not much math you have to do. Just a whole lot of plugging and chugging. Questions?
Are we going to do one more?
Let's eat.
Would you like to do one more?
No. Yeah, but it's almost time for lunch, so.
So you're saying, how about one more after lunch?
Yeah.
Okay. Which gives me the dilemma. I can't give you your assignment early because then no one will listen to me after
Just
lunch.
pull the problem up and then it'll be time for lunch.
Ooh, food for thought kind of thing. Like it.
Get out of here, I'm hungry.
Let's see.
Chicken nuggets?
Okay.
All right.
Good job.
When we come back from lunch, we'll look at one more example. And here's what that example will be. Of course, you'll have to remind me what it is after lunch.
Is this the homework or the?
This is the last example. Yes. Yes.
That's gonna be hard. What? That's not even our
Here we go. That's what we're going to do after lunch. That's the last example we're going to do after lunches.
I know, you need to know.
What was the equation?
3z4 minus 300z2. That sounds like a car.
Okay. Last example. Step 1. Is there anything we can factor out?
disease. Can't you take two?
I can take 2 z's out.
And 3.
It's not like this.
And I can take a 3 out. Very good. When I do that, what's going to be left in the first piece?
C2.
Gotta say, z squared. I want you to practice saying z squared. And what's left in the last piece?
100.
Minus. Now, step 2. What we have left, is it a quadratic?
No.
No. Could it possibly be squares or cubes?
Yep.
Which one?
Square.
Yes. 2 terms and they are both squared. What is a square root of 100? 10. Very good. So, come on. So you could rewrite that as 3z squared times z squared minus 10 squared. Difference of 2 squareds. Justin, what should our a value be? And then our b value. What should those 2 things be?
And B, 300.
Very good. Difference of 2 squares or cubes?
Squares.
Squares. So straight from the formula, is it a, what comes first?
A plus B.
A plus b, so z plus 10. And then what?
A minus B.
A minus b, so z minus 10.
Wait, I'm not going to look at that. I got to figure this out on my own.
Okay.
It's already up there.
But she's not going to look at it.
Oh.
That's all you have to do today. I will warn you. One of your 4 problems in just a second. One of your 4 will actually, step 1, take something out. Step 2, is it a quadratic? One of them will be a quadratic, just like your DOM. Because I want you to get used to actually acknowledging what each kind of factoring is. So, and you'll know if it's a quadratic if when you factor whatever out, if it's not just 2 terms, it's probably going to be the quadratic one. So, you are going to have one of those and 3 of these.
Hey, could we just do one more drawing?
Which one do you want to see? Sum of cubes, difference of squares?
Same as
Same as this one. We'll do a quick one. Same as this one. What do you think that one's going to be? Squares or cubes? I kind of jumped the gun. Step 1, nothing factors. Step 2, it's not a quadratic. Squares or cubes?
Squares.
That's you. You're the one who asked for this question.
So it would be like 7 squared.
That's right. So it'd be b squared minus 7 squared. What would our a value be?
8.
And our b value?
7.
There you go. If you look on your notes, difference of 2 squares. It was a plus b times a minus b. straight from your notes. If you have that one page of those three formulas, then all of them, once you identify what they are, the rest of it you just plug straight into the formula. All right. There are your 4 problems. These are due before you leave this class. I will be around in about 20 to 25 minutes to take a look at those.